from isolated gaseous atom. Okay, energy required to remove one electron from isolated gaseous atom. For example, we are having sodium, and that should be in the gaseous state. What we'll be making? We'll be making it Na plus gaseous plus electron. And the energy, of course, we are removing the electron from the atom, which is neutral. So some energy we have to give. We have to give some energy. So that energy, which has to be given, is known as ionization energy. Right. The point is, it should be only one isolated atom. It should not be like more than one atom. Like because that will be the ionization energy only. If we are having more than one atom, then the energy which is been using, that is not the ionization energy in that case. Okay. And the other thing is, suppose we are having 1 mole of an atom, right? It could be 1 mole also. 1 mole, if we take 1 mole, so how many electron will be removed? 1 mole electron will be removed. Electron will be removed as 1 mole. Then it is known as ionization enthalpy. Then it is known as ionization enthalpy. Enthalpy term we will be using for 1 mole of the reactant. Okay, like ionization enthalpy will be used for 1 mole of the reactant. So then we can use ionization enthalpy. So both are similar thing only. Ionization energy is for one atom, enthalpy is for 1 mole of atom. But like their orders will be same. If we are comparing ionization energy for two compounds, so the ionization enthalpy order will also be same, energy order will also be same. Okay. So now this is about ionization energy, some definition. Then what to do? We have to compare it, right? Along the period, along the group, in the ions, we have to compare. The point is, ionization energy depends on which factors. Like we can say, ionization energy, if we have to remove one electron, so can we just say if Z effective is more, Z effective, like nucleus to the outermost electron, that attraction is more, so removal of electron will become difficult. So we can say Z effective is more, ionization energy will be lesser. Okay, Z effective is more, ionization energy will be lesser. Second point, cell number. If we say about cell number, so cell number is more. Suppose cell number is increasing, so the distance from the nucleus to the outermost electron is decreasing. So that electron can be removed easily, right? So cell number increases. Wait, here. Ionization energy increases, na here. Cell number increases, ionization energy decreases. Third point, stable configuration, half filled and fully filled configuration. Can we say for half filled and for fully filled configurations, ionization energy is found to be more better. Ionization energy is found to be more. Why? Because they are stable, their configuration are stable. If we are removing the electron, we are disturbing the stability. So now the removal will become difficult. So difficult means what? We are not checking how much is the difficulty. We are comparing. So when we'll be comparing some between some atoms, then we have to keep these minds in our mind, right? Keep these points in our mind. Like half filled configuration is there. Okay, then we have to be serious about the comparison. Like it will be more, it can be lesser. And the fourth point is the shielding effect. Shielding effect. What is shielding effect? I have told you in the last class only. S orbital provide the greatest shielding, then P, then D, then F. What is the meaning of this? Electron present in S orbital is attracted uh, to a maximum amount, or we can say electron present in S orbital is attracted highly by the nucleus. Then electron present in p orbital is attracted quite lesser. Electron present in d orbital even lesser. Electron present in f orbital is very lesser. So as you can see, electron present in s orbital is attracted more. So removal will be difficult, right? So we can say, as this is the order of shielding, so this could be the order of the ionization energy also. This doesn't mean, please, this doesn't mean that you can compare anything. For example, you are having S2 configuration, you are having P4. We cannot compare like that. This is a general thing which I am telling you here, that this thing will impact our orders. When we will be comparing ionization energy, this shielding effect will also responsible for the change in the expected order. Okay, this is what the meaning of. And like, it is not the order of ionization energy that S will be always more than P, then D, then F. It is not like that. Shielding effect will affect or will change, can change the expected order. That's the meaning. Okay, so now these four things are there. On the basis of these things, in the periodic table, in periodic table, like when we are moving from left to right here, when we are moving from left to right, and when we are moving from down the group, left to right in the period means along the period. So along the period, one thing increases that we are very sure, Z effective increases. And as the Z effective increases here, ionization energy also increases. Right? And down the group, cell number increases. And cell number increases means ionization energy decreases. So generally what should happen? Generally, ionization energy increases along the period, right? Along the period, and ionization energy decreases down the group, down the group. Okay, so this is the thing which should be like it, but it is not the thing that it must followed. It must be followed. It's not like that. It is a general order, because we are seeing Z effective and cell number only. Here we are not taking the factors of half filled and fully filled, not the shielding effect. So some changes in the order can be there. We can see some changes. Okay. So now we start comparing, and this thing do not need to remember actually. You just remember one thing: left to right Z effective increases, and then you see by yourself, as Z effective is increasing, so removal of electron will become difficult here, right? Removal of electron will become difficult because nucleus is attracting the electron more now. Down the group down the group cell number is increasing, so electron is more away from the nucleus, so that can be removed easily. Okay, chaliye. Now let us start the comparison. Period 1, first period. In first period, hydrogen and helium is there, right? And we have to compare ionization energy. So what will be the order here? Hydrogen and helium. Helium is having, we can say helium is having inert gas configuration, stable configuration. So ionization energy of helium will be more, right? And we are moving from left to right also. So when we are moving from left to right, ionization energy increases, right? Left to right ionization energy increases, and it is stable configuration also. So by both the things, helium will be having more ionization energy. And not only helium, in every period, every inert gas will be having highest ionization energy in its own period. Helium will be having highest, then neon will be having highest in the second period, argon will be having highest in the third period, like that. So can you say one thing from here, that if inert gases are having highest ionization energy, then which element is having highest ionization energy in the whole periodic table? That's my question. In whole periodic table, which element is having highest ionization energy? That's my question. What is the answer for this? Varun is saying helium, and others? Afik,
Helium.
Vibhani,
Helium.
Ruba. Ruba, your voice is breaking. Okay, helium has the more ionization energy. Fine, very good. Helium has the highest because down the group IE decreases and left to right increases. So helium is at the top rightmost corner. So helium has highest IE. He has highest IE. Okay. Second period. Let's move on to the second period. Now, if we are moving on the second period, then we can see the element as lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These are the elements here. Okay. So what to do when we are comparing the ionization energy? Always write the electronic configuration. It is outermost only 2s1, 2s2, 2p1, 2p2, 2p3. It's 2p4, 2p5, and 2p6. Right. Okay. So now when we are having these configurations, so left to right I increases, neon should has the highest, but there will be variation at two for two elements, beryllium and nitrogen. Beryllium has a 2s2 configuration. The thing is, when you remove the electron from beryllium, it will remove from the s subcell, and s is also s2, fully filled. Then p1. After that, boron is coming, and just after s2, p1 is coming. Right? S has a good shielding, P has a lesser shielding. So removal of electron is easy from the P1 configuration. So I can just say here, I can say here one point that ionization energy for NS2 configuration and NP1 configuration, which is having more, NS2 is having NS2 is having more ionization energy than NP1 configuration. Right, beta? NS2 is having more ionization energy than NP1, means 2S2 is having more than 2P1, 3S2 is having more than 3P1, like that. And so its ionization energy will be more than boron, but it won't be more than other elements. Like we cannot say, sir, 2S2 configuration, that's its ionization energy will be more than all. No, it will be more than just its next element. Because left to right, one factor is also working, that is Z effective. Left to right, Z effective is also constantly increasing. No? That is also increasing. So beryllium and boron has more Z effective. But because this electron has been removed from S subcell, so here the removal will be difficult. Okay, so in this case, the ionization energy is more. Now, in the case of nitrogen and oxygen, again the same thing, beta. Nitrogen will be having more ionization energy than oxygen because again half-filled configuration 2p3. So because of half-filled, it is having some extra stability. So its ionization energy will be more than its next element only, than oxygen only. Okay. So because of the half-filled configuration, these element will be having more IE than its next element. Okay. So now what will be the order here? Can we just say about ionization energy? Yes. Lithium, boron, beryllium, carbon, oxygen, nitrogen, fluorine, neon. This will be the order. Left to right, there is increase, but there is a variation at two in two cases. This is because of NS2 configuration. This is because of NP3 configuration. Right? Is there any doubt in this order?
Also. Also.
Okay. And this is because of half-filled configuration. And why this one? We can say shielding effect. Like the explanation should also be correct. Shielding effect. Because we cannot say Z effective. We cannot say fully filled configuration. Answer will be shielding effect. Because S subcell is more close to nucleus. So removal of electron from NS2 will be more than NP1. Okay. Or we can say S has more shielding power than P. Shielding. Okay. Fine. Now, will you be doing for the third year, third period? Third period. Third period is what? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. So you have to do the comparison for this. You have to compare for this. What will be the order here?
Done, sir.
Done? Done, Ruba? Are you there? Varun?
Yes, sir. Done.
Vibhani?
Yes, sir. Done.
Okay, so I think the order is sodium, aluminium, magnesium, silicon, sulfur, phosphorus, chlorine, argon. Have you written the same order here?
Yes, sir. Yes, sir.
Fine.
Yes, sir.
So it's easy to do, right? We do not need to remember everything. We are able to understand now. Okay, first, second, and third period is done. Then let us move. Let us move on to the group wise. Okay, let's go for the groups. Before going on through the groups, we can compare IE2. IE2. This voice is also coming to you also. This WhatsApp notification. Is it coming there also?
No, sir.
No. Okay. IE2 comparison. So IE2 comparison means we have to remove the second electron now. What is IE1? What is IE2? What is IE3? From the atom or any ion also. Like it can be ion also. It can be Na plus. It can be aluminum plus 3. Any ion or any atom, whatever it is, if you are removing first electron, that is I1 of that. If you are removing second electron, that is I2 of that. If you are removing third electron, that is I3 of that. So for example, they are asking that compare the ion I2 of these elements, nitrogen and oxygen, compare the I2 for these. What to do? We have to compare for the removal of second electron. If we see the configuration and if we compare from here, so answer will be wrong here because you are comparing for the first electron removal. Like if we compare from these configuration, then we are comparing actually IE1. We have to compare IE2. So what to do now? You just remove one more electron. You remove one more electron. Then it will become 2p2. It will become 2p3. Now in this case, 2p2 and 2p3. In this case, now the electron, if you see from here, removal will be the second electron. Like the second electron will be removed. So this is the configuration from where we have to compare, right? So when you have to compare I2, you remove one electron, then whatever the configuration is there, you compare for that. Suppose we have to compare I3, then we will remove two electron first. Then whatever the configuration will be becoming, we will compare from that configuration. 2p2 and 2p3. So we can say I2 will be more for oxygen now than nitrogen because oxygen is now 2p3. 2p3 and 2p2, which is more? 2p3 is more. Have you understood here, everyone, this case?
Yes, sir.
Yes, sir.
Fine. So will you be comparing I2 for this one? Silicon, phosphorus, sulfur, chlorine. For these four elements, you have to compare the I2. Done?
Yes.
Varun?
Done, sir.
Okay. Okay, so let us see. Silicon is what? Silicon is 2p2 here. Phosphorus is 2p3. Sulfur is 2p4. Chlorine is 2p. Not 2p, 3p. 3p2, 3p3, 3p4, 3p5. So from this configuration, if we are comparing, that means we are comparing I1. We have to compare I2. So remove one electron. It will become 3p1, 3p2, 3p3, 3p4. So if we are comparing IE2, that means IE2 will be highest for what? Like silicon will be lesser than phosphorus, then sulfur will become more than chlorine. This will be the order. This will be the order, right? Have you found the same order, everyone?
Yes, sir.
Yes, sir.
Varun?
So the sulfur, I got confused.
But now it's clear.
Yes, sir. Clear.
Ruba? Ruba, are you able to hear anything?
Sir, I'm able to hear you. Sir.
You can hear me,
Yes.
but your voice is breaking.
Sir, no issues.
Comparison of ionization energy along the group. Don't worry, for D block cases, we do not have to compare the IE. We have to just compare for some orders only. For some orders. And here, very important thing. For along the group, if we are having, so we are having first group, second group, then 10 groups are there for the D block, then 13 to 18 are P block. So ionization energy decreases down the group, it decreases. It decreases down the group regularly for every period in S and P block element except 2, right? So we can say IE decreases down the group for S and P block element, S and P block elements except what beta? Except group number 13 and 14. Except group number 13 and 14. Okay. So yes. Now what to do? For 13 and 14 we have to see. And in the last class we have seen that group number 13, why that have some variations, because it comes just after the D block and F block subcell, and D and F has poor shielding. D and F has poor shielding. And then the other groups which are after the 13th, they will also feel some effect. Some contraction will also be there, but that effect will be lesser than the 13th. Okay, so if we are seeing the comparison of IE for group number 13, 13 number group, boron, aluminium, gallium, indium, thallium. So what should happen here? Boron and aluminium, boron should have more because down the group it decreases. Aluminium and gallium, it was expected that gallium will have lesser, but gallium is having more. Why? Because just before the gallium, D is coming. D10 are fully filled. Like D subcell is fully filled before gallium. D has poor shielding. D electrons will consume the forces of attraction lesser, which is coming from nucleus. Means nucleus forces of attraction will go outside more for the D block cases, right? And what is just after D10? Gallium. So electron present in gallium will be attracted more from the nucleus. So that is why the size was decreased. So because of the same reason, removal of outermost electron is difficult from the gallium. Similarly, gallium and indium, which should have more, indium should have lesser. Then before thallium, F is there. Before thallium, F has been introduced. So now again, the effect will be seen. Indium and thallium will be having more, right? So this is the order, and we can compare the IE for every element in the group number 13 by a W shape graph. This is Z atomic number, this is ionization energy, and we are having a graph like this. Have you seen it before? Okay. This is boron, aluminium, gallium, indium, thallium. Okay. So from this W, say please, this W is should not be very symmetrical here. Please, you do not have to make it like that. Okay, where whatever the position is, you have to match that position in your notebook while making the graph. It is like that. Okay, like this, boron is having more. Boron is having more. Boron is having highest. Then it is the thallium. Then it is the gallium. Then it is the aluminium, and then it is the indium. So by this W shape, we can remember the uh, we can remember the order. So boron and aluminum should have lesser, it is having lesser. Aluminum and gallium should have more, it is having more. Gallium and indium should have lesser, yes. Indium and thallium should have more. But what will be the actual position for every element? That we can learn from this graph. Right, everyone? Is it clear now? Group number 13.
Yes, sir.
Yes, sir.
Yes.
Okay. So now group number 15. If we talk about group number 15. So not 15, 14. Group number 14, what the elements are there, beta? In group number 14, elements are carbon, silicon, germanium, tin, and lead. So, before germanium, gallium is there. Before lead, thallium is there. So, some impact will also we can see on the germanium and lead. But which will be having more impact? Lead. Because before thallium, F has been coming. F. F is having the weakest shielding. Before gallium, D is coming. And D and F, which is having more poor shielding? F. So impact of shielding or impact of contraction is more for lanthanides. Lanthanide contraction is more than scandide contraction, because lanthanide contraction is because of F subcell. So we can say before thallium, F4F has been filled, so thallium will be having more impact, and the impact will reach on the lead also. Because of that, we can see, or we can see the order here as decrease, decrease, decrease. But tin and lead is having more. That's the only thing. And like all other cases are just like that: carbon, silicon, germanium, tin, lead. It is just like a kind of hockey. So carbon, silicon, germanium, tin, lead. So this is ionization energy. This is Z. Okay. Right. And in all other groups, if we talk about, so it decreases down the group. So there is no issue, no doubt. For other groups, IE decreases down the group. Fine here. So I think comparison of ionization energy along the group and along the period is done. Okay. Now for ions, we can see. For ions. In ions, there is cation. You tell me one thing here. Suppose A is there, A plus is there, A plus 2 is there. Okay. Anion, B is there, B minus is there, B2 minus is there. You have to tell me the ionization energy order here and here. I will tell, but before that, you have to tell me the order. What will be the order, Varun, for cations?
Sir, for cations, A plus 2 will have least, then A plus will have.
A plus 2 will have least IE.
Yes, sir.
Means removal of electron from A plus 2 is easy, easiest.
Yes, sir.
Okay. Are you
Then
sure?
A plus, then. Sir?
Are you sure for this? Like, have you thought what order you are telling? Like you have just
Yes, sir.
okay, fine. Afik,
So A plus 2 will have highest, then A plus, then A.
Vibhani?
A plus 2, A plus and
A plus 2?
A plus and then A.
Ha. And Ruba? Ruba is not there. Why Ruba is not there? Okay, so yaar, Varun, yaar, like I expected the correct answer for this. A plus 2 will be having more than A plus than A. Because as you can see, number of proton are same, but here electrons are lesser, right? And it is a cation. It is electron deficient. So you are removing from the electron from the deficient species, which will be difficult now. Or you can just see, for example, we are comparing it for Na and Na plus, which is having more I. They are having 10 proton, sorry, 11 proton, 11 proton, but electron number is changed. So now 11 proton are holding 10 electrons. So the hold is stronger. Na? If the hold is stronger, IE will be more here, Varun.
Okay, sir. So
For
I thought they'll have
you thought what?
extra electrons so easily. I thought they'll have extra electrons, so they lose easily.
Oh, really? A plus 2 is having extra electron. Cation. Do cation have extra electron? Varun yaar. Cation means removal of electron or addition of electron? Like by mistake it
Sorry,
happened,
sir.
or like you think like that only that cation has more electron?
No, sir, no, sir, by mistake.
हाँ यार please यार.
Yes, sir, yes.
Okay, B minus and B2 minus. So in this case, B2 minus is having more electron. So it is an ion. Protons are same, but electrons are increased. So hold is becoming lesser. So electron removal becomes easy. So the order will be like that. Isoelectronic species. Isoelectronic species. If we talk about isoelectronic species, then we are having what species here? We are having, for example, I'll be asking to you, Varun, you have to tell me F minus, O2 minus, N3 minus, Na plus. Everyone just write your order in your notebook. I'll be asking you. So A, B, C, D, E, F. What will be the order of ionization energy here, Varun? Today papers are released, JEE mains. Okay, so what will be the order, Varun? Which is having highest?
Uh, N 3 minus
N3 minus is
highest.
highest. Okay. Afik,
So Al3 plus.
Vibhani,
Al3 plus.
Sir, so Al3, then Mg2, then Na2, F minus, then O2 minus, then N3 minus.
yes. But beta, every time we do not get the second chance, right? In the exam paper, we have to be like write the correct answer. So like this is the correct order. Have you understood it, Varun?
Yes, sir, I understood.
Very good. So for isoelectronic, what we can see, like the thing, if it is not clear, I am again giving you the explanation for this. These are the species which are isoelectronic, means electrons number are same. But what is different? Something is still different now. Protons number are different. Aluminium has 13 proton, but 10 electrons. So hold is stronger in the case of aluminium plus 3. So as the proton number is more, hold is strong. Proton number is less, hold is lesser. So we can say one thing for isoelectronic, if Z is more, means atomic number is more, so removal of electron will become Z is more, means hold is strong. So removal of electron will become difficult. So ionization energy is more. Z means atomic number. So atomic number is more for F, then E, then D. Like that we can do. Right, Varun?
Yes, sir.
Okay. So next we are having application of IE. Application of IE. Application of IE. My handwriting is not good. I have to use it. Application of ionization energy. Okay. So there are three applications of ionization energy. First, metallic nature. So beta in this thing, like metallic nature means if we can say metals are the one which loses the electron. So can we say one thing here? If ionization energy is lesser, metallic nature is more. Right? The metallic nature is more. Or can we say one thing also? If ionization energy is more, then non-metallic nature is more. Or we can say metallic nature is lesser. At least we can say this. Because if metallic nature is lesser, that simply means non-metallic nature is more. Right? Like we do not need to remember this, please. If ionization energy is lesser, means energy required to remove the electron is lesser. That means it will be more like metallic. Okay. So in the periodic table, when we are moving left to right and when we are moving down the group. So what is the scenario? Left to right if we are moving. So Z effective increases. As Z effective increases, ionization energy increases. So as ionization energy increases, so metallic nature decreases. Metallic nature decreases means non-metallic nature increases. So this is the reason we see non-metals in the rightmost. And on moving down the group here, on moving down the group, cell number increases, ionization energy decreases, so metallic character increases. Or metallic character increases means non-metallic character decreases. Like metallic is increasing means non-metallic is decreasing. So that is the reason we find we find metals along the group. So if anyone is asking hydrogen, or we can say lithium, sodium, potassium, rubidium, cesium. If we want to see the metallic nature here, what will be the order? Order will be like this here. Right. And then, for example, boron, carbon, nitrogen, oxygen, fluorine, non-metallic nature. I know that you are very comfortable in these things, but please, if we are doing it, we should do it complete. Okay, so this is the first application of IE, which is like by which we can compare the metallic nature. Second application, stable oxidation state. Oxidation state means like generally oxidation state, if it is positive, that means removal of electron. Like suppose aluminum plus 3 is there, Mg plus 2 is there, Na plus 1 is there. Alkali metals has plus 1 common oxidation state. Alkaline earth metals, beryllium, magnesium, calcium, strontium, they have plus 2. then aluminum has +3. So why they are having these oxidation states? Like we know the reason, because after removal of one electron, they get the inert gas configuration. For alkaline earth metal, after removal of 2 electron, they get inert gas configuration. For aluminum, after removal of 3 electron, they get again inert gas configuration. But like suppose some random case is given, suppose for A element they are asking, then how to do? So for this, IE n minus 1, or we can say IE and IEn minus 1. Like they are just conjugative ionization energy, I3, I2, I4, I3. The difference, if the difference is more than 10 electron volt, that means the difference is large. Then in that case, stable oxidation state is n minus 1. Second scenario is what? If ionization energy n minus ionization energy n minus 1, this gap is less than 3 electron volt, less than 5 electron volt it is. Less than 5 electron volt, then stable oxidation state is, it was 4 electron volt, sorry, 4. Less than 4 electron volt. Then stable oxidation state is n. And it is very easy. You will be able to understand. Just see here. Suppose IE3 and IE2 is there. Okay. And the difference is coming to be 15 electron volts, suppose. So this what from here we can say that what will be the oxidation state? Common oxidation state +2. This means stable oxidation state is +2. And like we can understand it very simply. I2, I3. So removal of third electron. If you are removing third electron, you have to give more energy. So removal of second electron is easy. That means like the difference is larger, no? But suppose I2 and I3, the difference is very less. That means third electron can be removed easily. Of course, it is more than I2, but I2 and I3 gap is lesser. That means third electron also can be removed. So IE, like the stable oxidation state, will be the next one. So IEn and n minus 1. If the difference is lesser, that means the next electron can be removed. But if the difference is more than 10, that means the next electron cannot be removed easily. Right? So for example, IE, for example, we can have IE4 minus IE3. This is 1.5 electron volt. That means your fourth electron is also removed easily. So then stable oxidation state is +4. Have you understood this thing here? Everyone? Have you understood this application? We can comment about the stable oxidation state of any atom. Vibhani,
Yes, sir.
Varun,
Sir.
Afik.
Yes, sir.
Okay, so third application is prediction of number of electron in valence shell. Example, you just see one thing. This is a case we are having. Magnesium has how many electrons here? There is a nucleus. How many electrons are there in magnesium? 1s2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. It is magnesium, right? 1s2, 2s2, 2p6, 3s2. This is magnesium only. So if we remove one electron, that electron will be removed from here. Suppose this is the removal of first electron. Then this is the removal of second electron. Then if you are removing the third electron, that third electron will be removed from the inner cell, like the penultimate cell, outermost cell, penultimate cell, pre-penultimate cell. So this second cell will be penultimate cell here. So this electron is removed from the penultimate cell. So in this case, the difference of the ionization energy, which was in between 1 and 2, and 2 and 3, the difference is very large in 2 and 3, because there is a difference of cells now, and that is even a stable configuration. That is a configuration of inert gas also, 1s2 2s2 2p6, which is a inert gas configuration. So here IE1, then IE2 is more, of course, because when we have removed one electron, second electron removal will be difficult than the first one, but IE3 will be very, very larger than IE2. Okay, so when? So what? How the question will be asked? Example: if ionization energy data is given as like I1, I2, I3, or we can say like that: 120 I1, I2 180, I3 220, I4 330, I5 1080. Valence electron. Number of valence electron. Can you tell me the number of valence electron here?
So 5.
5. Vibhani?
5.
Varun?
Or is it 4?
4. Very good here. Varun. This time Varun killed it. It will be 4. Like, removal of the fifth electron requires very high ionization energy. Means fifth electron is present in inner cell. Na? Outermost cell contain 4 electron only. So outermost cell, electron present in outermost cell are the valence cell electrons. So valence cell electron will be 4, not 5 here. These are the valence cell electrons. Got it? Afik and Vibhani?
Yes.
Yeah.
Okay. So again, this is the application, and we can solve some question now, just one or two question. Question number 50.
So is it multiple correct?
Yes, it is multiple correct. Okay, done. Done.
Yes.
Afik.
Yes, sir. So what is ionic mobility?
We have seen na, that hydration enthalpy, hydration energy was there, and in that case, like the one which is having more hydration, the ion which is get more hydrated, that will be difficult to
Oh,
move.
yes.
So its ionic mobility will be lesser. Okay, so of Varun,
Yes, sir.
done.
Yes, sir.
Okay, so let's see the answer. What is your answer, Vibhani?
Sir, A and
A and C. A and
yes, sir.
Varun, what is your answer? A B. Afik,
So CD.
C D. Okay. So for metallic character, if we see beryllium, magnesium, sodium. So sodium is there, magnesium is there, and then beryllium. Where is beryllium? Beryllium is here somewhere. Then silicon, silicon is here. Then phosphorus is there. So phosphorus will be having least. Then silicon will be having more. And then among them, down the group metallic nature increases. So magnesium and sodium has more than beryllium. And among magnesium and sodium, which is having more? Sodium is having more. Like sodium is having highest. This is having highest here, leftmost and downmost. Right? Sodium is having highest. Then beryllium and magnesium. Magnesium is having more. Then beryllium is having lesser. Then these are having even lesser. Right? There is no contradiction here. Phosphorus and silicon should have the least. Then among beryllium, sodium, magnesium, sodium should have the highest. Beryllium and magnesium, magnesium should have more. This is correct here. Rafik.
Yes,
Ionic
sir.
radius. Ionic radius is also correct. Like this is also correct. AB. Now for C. Second ionization energy. If you remember, beryllium was having more than boron and it was first IE. And what is boron? Sorry. Beryllium and boron. Beryllium is 2s2, boron is 2p1. So if it is like that, beryllium is having more IE1 than boron. So if we compare IE2, then it will become 2s1, it will become 2s2. So IE2 is more for boron than beryllium. Right? So this is wrong. Lithium, sodium, potassium, rubidium, cesium. Smallest ion, this is lithium. This will have more hydration. If you remember, hydration enthalpy is directly proportional to charge, inversely proportional to size. So hydration is highest in the case of lithium. If hydration is highest means its mobility will be least. So this is correct. So answer will be A, B, D. Got it, everyone?
Yes, sir.
Okay, so atomic size and ionization energy is done. Okay then. Bye. Good night.